Hi guys, welcome to another short video clip of MrLopezClasses.com. Today we are going to talk about some concepts that create confusion. The concept of bonding, grounding, ground, the concept of current carrying conductor and non-current carrying conductor. In order to understand those concepts, I want to check quickly a DC circuit and other AC circuit. And we are going to verify how is the flow of electron is in each circuit, in particular in the AC and the DC circuit. I have in the screen right now a DC circuit, and we are going to check this is the battery. This is a battery of 9 volts. And I have the switch or interrupter. I install a fuse over there in that point, and an ammeter. Remember that the ammeter should be installed in series in the circuit. In series, you need to interrupt the cable and insert the ammeter. Okay, this is the ammeter, and after that I have a load. In this particular case, a light bulb. The resistance of the light bulb is 10 ohms. We are going to use the ohm law. The ohm law states that the voltage is equal intensity times resistance. Okay, and if the voltage is 9 volts and the resistance is 10 ohms, how much is the intensity? Is 9 volts divided by 10 ohms is 0.9 amps. Okay, let me check if that's true according with the ohm law. I am going to close the switch, and yes, I have 0.9 volts in the positive cable, the red one. The red one is coming between the positive terminal of the battery and enter in the positive conductor of the load. Motor or light is the load. This is the positive is here. This is the red cable. And the current is 0.9. Oh, let me check the return or a black cable or ground cable in my DC circuit. If the black one is in between the case of the light bulb, return black cable, black cable, black cable, and enter in the negative of the battery. I install other ammeter in the negative, and you can see 0.9 amps in both of them because it's a series circuit. Oh, wow. Then, the positive conductor, the red one, in a DC circuit is current carrying conductor. The negative conductor or black one in a DC current, in a DC circuit is current carrying conductor, 0.9 amps. Both of them with 0.9 amps. Oh, great. Both of them are current carrying conductor. And of course, if you check with the voltmeter, this is the negative. This is the negative, and this is the positive. We are going to check here. You see the signal is a straight signal. This is the shape of the wave. Straight is in this particular case 9 volts. It's 9 volts. You see, it's pretty close to 10. It's 9 volts because it's a straight signal. It's DC, direct current. This is the current of DC circuit. We are going to analyze other circuit. We are going to analyze an AC circuit, and let me I open the switch. Okay, in this particular circuit I have the source of power, AC power, hot, neutral, and ground. The source of power is that circle. AC current, you see the shape of the current is the shape of the current. The sinus signal positive, negative, positive, negative. Okay. If you remember, in my book of marine electricity, the AC current is alternating current, pass from the positive side and goes into the negative side, positive side, negative side is alternating current. Okay, I have the source of power, I have the ammeter, I have the switch, and once again a load. In this particular case, I put a light bulb. It could be a fan, or blower, or motor, is a load. and this is the return. Okay, remember, in AC, the supply is the hot, is the black cable. The return is the neutral, is the Y, is the return. And the ground is the grounding conductor. Now we are going to talk about that. Okay, in this particular case, but we are going to close here. Oh, nice. You see the movement of the electrons? The movement of the electrons is back and forward, because it's an alternating current. Back and forward, back and forward. Yes, that's the movement. And you see that in this particular case, the current fluctuates in between minus 0.9 and 0.9 positive, because it's alternating current. The current fluctuates in minus 0.9 and 0.9 positive. Let me check. I have, in this particular case, a voltmeter. I am going to connect the voltmeter here in the return, and the other one here in. And look at the signal. The volt go to positive, negative, positive, negative, positive, negative. Wow! This is the oscilloscope to read voltage. Okay, let me check with the oscilloscope. We are going to check amps. This one, amps. And I am going to check the amps here. Oh, the amps fluctuate in minus 0.9 and 0.9 positive. Positive, negative, positive, negative. Oh, okay, because this is alternating current. It's clear, my friends? Now we are going to check quickly in this diagram. I have the same circuit. The circuit of a DC. And once again, I have the battery here. This is the battery. And I have the switch, I have a fuse, and this is the load. In this particular case, it's a motor, or it's exactly the same. Okay, and this is the return. This is the black cable, or return, to the negative of the battery. Okay, the positive cable, the red one, enter in the positive terminal of the motor and return in the black one. Okay, both of them, the black and the red, are current carrying conductors, because remember in the previous animation, the current in the positive 0.9 amps and the current in the negative 0.9 amps is constant in that particular circuit. Okay, wow, both of them, the positive red one and the negative black one, both of them are current carrying conductors. What about that green cable that I have in the majority of the appliance and devices? That green cable is the cable that is used to drain static electricity accumulated in the case of the equipment. The static electricity should be drained with that green cable connected to the ground of my home. You remember where is located the ground in your home? Is that copper rod that is inserted in the ground in the backyard of your home or your building, and the ground bus bar of the AC panel is connected over there outside to the ground. This is the ground in your home. In your boat, the ground is the sacrificial anodes located outside. Those sacrificial anodes located in the transom of the boat. This is the ground in your boat. Okay. The grounding conductor, the green cable, is the cable that connects the case of the equipment with the bonding conductor, and the bonding conductor is connected with a cable with the sinks, with the ground outside. Alright, now it's clear. What is the function of that green cable? Drain static electricity. Or, in some cases, if you have a short and the hot line touch the case, or the positive touch the case, it is DC, that cable, the green, drain that current quickly into the ground. The function is drain the grounding. Okay, this is the DC circuit. Okay, let me check what happened in an AC circuit. It's the same. I have an AC circuit. This is the main breaker, and those are the individual breakers for fan, for lights, for motors. Okay, I am going to activate this motor. To activate the motor, I need the hot line coming from the breaker for that motor, the neutral coming from the neutral bus bar, and the ground is connected from the case of the motor into the bonding conductor. Okay, let me analyze. The current enter through the black one, enter in the coil of the motor, and return to the neutral. The neutral is the return. Both of them are current carrying conductors, the black one and the white one. In American power. In European power is the brown and the blue. Brown is hot and blue is return. It's exactly the same. And what about the green? The green is the cable used to drain static electricities or charge into the bonding conductor, and the bonding conductor connected with the sink. Wow, this is the explanation of current carrying conductors and non-current carrying conductors. Great, no? Okay, we are going to check quickly that explanation. What is the meaning of bonding? Bonding is when you connect all the metallic elements in my boat into the bonding conductor, and the bonding conductor should be connected externally with the sink. That picture. In that picture, you see that diagram. All the metallic elements inside of my boat connected together with the bonding conductor. This is bonding. Grounding is when that bonding conductor is connected externally with the sacrificial anode. This is grounding. And ground, of course, is the reference to ground. In your boat is the sacrificial anode. In your home is the copper rod. Now you have clear the concept of bonding, grounding, and ground. I hope you enjoyed this explanation. If you have more questions, please ask the question into my email, info@mrlopezclase.com. And if you enjoyed this video, make a click. Thank you.